In a previous video, I was talking to you, we're talking about Euclid Book 7 definitions. We were talking to you about squares. Okay, this is part of Euclid Book 7 definitions. Now, in that particular video, I had actually told you that a little number 2 as a superscript to a letter x, which would be a variable, is not just a pretty little number. It actually has meaning. But I wanted to elaborate on squares because I wanted you to be able to better visualize not only what Euclid was talking about, but what a square actually is. Okay, now I told you in the last video this is about square areas. This kind of stuff would be used for agriculture or for mapping or anything like that. Okay, and there are other uses for it as well. But the thing is, you have to get past the idea that it's just some kind of a funky little number above a variable. Scrap that. You're way past that now. Alright? So, what we're going to start off with here is a 1 inch by 1 inch physical square. This is a 1 inch by 1 inch physical square. Obviously, it has shape, it has definition, it has meaning. Okay? Alright, now what we're going to do is we're now going to make a 2 inch by 2 inch physical square. How are we going to do that? Alright, we are going to add 3 more units. And these will be 3 more unit squares. And each one of those unit squares is going to be 1 inch by 1 inch. Okay? I'm going to now draw you a 1 inch by 1 inch unit square. This is going to be one of the 3 unit squares we're going to draw around here to make this physical square into a 2 by 2 physical square. Let me draw the other 2. Now let me say this right. What we have done is we have added 3 unit squares to this physical square right here to make this into a brand new 2 by 2 inch physical square. Okay? Now each one of these unit squares was exactly 1 inch by 1 inch. It was 1 inch across, 1 inch down. And those dimensions were exactly the same as the original physical square we had, which was also 1 inch by 1 inch. Now then, let's say we wanted to take this 2 inch physical square, we wanted to make it into a 3 inch physical square. Well, what we'd have to do is we'd have to add 5. Excuse my crude drawing here. We'd have to add 5 more One, 2, 3, 4, 5. We'd have to add 5 more unit squares to our 2 inch by 2 inch physical square to make a 3 inch by 3 inch physical square. Now there are 2 patterns you should notice on this immediately. First of all, you should notice the number of squares we'll have to add each time to make the new physical square. So each time we increase the number of unit squares that we have to add to the previous physical square to make a new physical square, we start having a pattern. We had to add 3 unit squares to the original 1 inch by 1 inch physical square to make this into a 2 inch by 2 inch physical square. We had to actually add 5 unit squares to the 2 inch by 2 inch physical square to make this into a 3 inch by 3 inch physical square. If we were to make this into a 4 inch by 4 inch physical square, we'd have to add 7 more unit squares to do it. See the pattern? These are odd numbers, and they're consecutive odd numbers, starting with 3, going on to 5, going on to 7, and we could go on and on and on. But there's something else you should have noticed. Okay? What is 3 plus 1? Well, it's 4. Okay. So we added 3 unit squares to this one physical square, and therefore we got the number 4. Okay? which 4 is 2 squared. When we added 5 more to these 4, we got 9, which is the next square. And of course, if we do the 4 by 4, we get 16. Because 7 squares plus 9 squares is going to be 16 squares. So as this number goes up, so does this. Alright. Now, let's take this in reverse, shall we? Okay. Now let's say we have a 1 inch by 1 inch physical square. Now I'm going to go ahead and erase this real quick. We're going to draw a 1 inch by 1 inch physical square, but we're going to put it under a magnifying glass. That way you guys can see it. We're going to pretend that this is a 1 inch by 1 inch physical square, but it's been magnified so you guys can actually see it. Now, we're going to divide all 4 of these sides by half. I'm going to divide them by half. Now that means that the unit squares here are going to measure a 1/4 inch by a 1/4 inch. This side will be a 1/4 inch, this side will be a 1/4 inch. Because remember, we're magnifying a 1 inch square here. Alright. Now if that be true, the size of the unit square will become smaller. However, the count of unit squares will become bigger. Because now, instead of having one unit, well, it'd be 1 unit and 1 physical square, okay, it'd be both a unit square and a physical square, we now have 4 unit squares, but the unit squares, the size of the unit squares is smaller. We have more of them, but it's smaller. Likewise, I'm going to erase this. Let's say we divide each side into 3 equal parts. Okay? We've got this 1 inch by 1 inch square. We're dividing all these sides up into 3 equal parts. The size of the unit square will get smaller, but the number of unit squares will get bigger. Okay? Let me say that again. The size of each unit square will become smaller. There'll be less area in each one of these unit squares, but the number of unit squares will get bigger. So it will still hold with the same pattern where you have 3, 5, 7, and of course the square numbers being 4, 9, and 16. But now the unit squares themselves are getting smaller, yet their count is getting larger. See what I mean? So basically we're creating more squares inside the original physical square, but the unit squares we're creating are going to be actually smaller than the time previous. And that's what this is all about. Okay? Now, these are properties and things that you need to keep in mind, because eventually I'm going to teach you about a harmonic series, and one of the harmonic series that I'm going to actually teach you about will be this. And hopefully you'll grasp these concepts and visualize math rather than just memorize a bunch of meaningless numbers. Okay. hopefully you got all this. If you have any questions, leave them down here in the comments below. I will tell you more in a future video, so stay tuned.